So let's do a couple of substitution problems. The whole purpose about U-substitution is that you kind of want to look for the derivative and its original function. If we do look at this problem, we kind of see that here we have this x cubed minus 4, and if I were to take the derivative of that, I get a 3x squared, which just so happens to be over here. So the whole purpose about U-substitution is that you kind of want the original function to be your u and your and the derivative to be your du. So let's first look at the thing under the square root. We're going to set that equal to u. So u equals x cubed minus 4. And if I take the derivative of that and I take the differential, du is equal to the derivative of x cubed is 3x squared. And then this goes away. And then I'm going to write dx. Okay, so it kind of looks like I have everything that I want. Now let me rewrite this a little bit better so that you can see you're going to have integral, and then let me just rewrite this as x cubed minus 4 and then times 3x squared dx. And you can see that by direct substitution, we know that 3x squared dx, well, that just equals du. So this entire thing is just going to be substituted with the du. Now everything inside here is just this u. So I'm going to put in this u, and then I have the square root left over. So what I just did, I just substituted everything with the u and du, and I made the problem much more easier. So what I'm gonna have now, let's rewrite this square root of u to u to the 1/2 du, and then let me take the antiderivative. So I'm gonna take u to the 1/2 plus 1 divided by 1/2 plus 1, and I'm gonna add a plus c. So I'm gonna have u to the 3/2 divided by 3/2 plus c. This is just gonna give me 2/3 u to the 3/2 plus c. And now we're almost done, but notice that I don't want it in terms of u. I initially started with x's, so since I know that u is just equal to that, I'm just going to plug it back in. 2/3 x cubed minus 4 to the power of 3/2 plus c. And this is going to be my final answer. Okay. All right, so let's try this other problem. This one's a little bit more involved. Looks kind of scary, but something that you might want to consider doing with these types of problems is that, especially when you have fractions, we can just bring it to the top the following way. So you can have integral, I'm going to have 3 cosine of 2t, okay, and then I'm going to bring the denominator up to the top, so I'm going to have 1 plus, whoa, I don't know why it's doing that. Let me just erase this again. Maybe it's just, let me use the tip again. Okay, so I'm going to have integral 3 cosine 2t, and then I'm going to bring this top part to the top. So I'm going to have 1 plus sine 2t to the power of negative 2 dt. Okay, so that everything is up to the top. All right, and now what I'm going to do, usually anything that is within parentheses raised to some power or under the square root is a thing that you kind of want to make your u. So I'm going to let my u be this thing. All right, so u is going to be equal to 1 plus sine 2t. Sorry, I had to pause the video, but I think it can write better now. So u equals 1 plus sine 2t, so that's what I let u equal to. So now I'm going to take the derivative of this, so du, the derivative of 1 is just 0, the derivative of sine is cosine, so it's going to be cosine, cosine of 2t. I'm going to multiply it by the chain rule because you have the 2t in the inside. I'm going to multiply it by 2, and I'm going to have dt at the end. So let me write it a little bit over here. So so I'm gonna say u is gonna be equal to 1 plus sine 2t, and du is gonna be equal to cosine 2t times 2 dt. Okay, so now what I'm gonna do, I'm gonna plug everything in here. So I have integral, let me flip these two, so I have this 3 there. I'm gonna flip the 1 plus sine 2t the negative 2, then I'm going to have the cosine 2t dt. Okay, so now if you notice here, I want to do this direct substitution to this cosine 2t dt. So I see this cosine 2t and I also see this dt. Now I don't want, that's what I want, but I don't want that 2. The 2 is kind of like in the way, so let me move it over. So what I'm going to do, I'm going to divide by 2 to both sides. So I'm going to have 1/2, 1/2 du is equal to cosine 2t dt. So now I know what cosine 2t dt is. That's just 1/2 du. So I'm going to substitute that with 1/2 du. Whoops. This thing is just going to be 1/2 times du. This 1 plus sine 2t, well, that was just equal to this u. So I'm going to substitute all that with u raised to the power of negative 2. There is a 3 right there, which isn't really doing anything. So the 3 nothing's going on with that, and then integral. All right, so what I end up getting is the following. Let me use a different color. So what I end up having is, let me pull out everything that's a number. So here's a 3, here's a 1/2. Let me pull it out. That's 3/2 integral of u to the negative 2 du. That's what I ended up with. So I changed something that was really, really complicated to something that was more easy. So I'm going to have 3/2. I'm going to take the antiderivative of this u to the negative 2 plus 1 divided by negative 2 plus 1. Then I'm going to have a plus c. So I'm going to have 3/2. This is just going to be u to the negative 1 over negative 1 plus c. So I get negative 3/2 u to the negative 1 plus c. Okay, and now what was u originally? U was just 1 plus sine 2t. So I have negative 3 over 2 times 1 plus sine times 2 of 2t to the power of negative 1 plus c. And then to finish it off, negative 3 over 2, 1 plus sine 2t, and then that's just to the power of 1 plus c. So just getting rid of the negative power. Okay, all right, and that's basically all what U-substitution is about. You just want to look at the derivatives, see what the derivatives are, and the functions and its derivatives should be inside the integral. So the hard part, I think, is trying to identify what u is and what du, and because then du you can try to manipulate it to try to figure it out. And usually, if you let u equal the derivative itself, and then you try to take the derivative of that, you'll see immediately that you didn't quite get what you wanted, so you would have to go back. So even if you mess it up, it's okay. You can probably, if you see that taking the derivative of the function doesn't give you the other function, then you should swap them. Okay, that's basically what U-substitution is.